we are asked to find dz dt using two different approaches, using the chain rule and by substitution. I want to start with the chain rule. And so I'm going to draw my dependency diagram. I have an independent variable t, which I plug into this vector equation to get an x and a y. And then those x and y's get plugged into this function on x and y to give me a z. I can find a partial of z with respect to x. I can find a partial of z with respect to y. And I can find dx dt and dy dt. And then my chain rule is the partial of z with respect to x times dx dt plus the partial of z with respect to y times dz dt. When we're writing out a chain rule and when we're writing out the parts of a dependency diagram, it's very important that we make clear which things are partials and which things are derivatives. So be careful when you're doing this. So I need a partial of z with respect to x. Well, the derivative of x times a constant is that constant. I need a partial of z with respect to y. For the same reason, I'll just get x. And now I need to take derivatives of these two functions. So dx dt is e to the t, and dy dt is, well, let's see, that's going to be 1 over e to the t. Right? Thinking about this as a minus e to the minus t, take the derivative, use the chain rule, we just get 1 e to the minus t. So I'm going to write it without that negative in the denominator. And now I'm ready to write down my chain rule. So it's y times e to the t. All right, well, y is minus 1 over e to the t times e to the t plus x is e to the t times 1 over e to the t. That's minus 1 plus, I get 0. All right, not very interesting. The derivative is 0 for all values of t. That's super boring and actually tells me something about the z's that I find out when I directly substitute. And maybe you noticed this already, but if z is x times y and x is e to the t and y is minus 1 over e to the t, I just get minus 1. So of course the derivative of a constant is 0. And wait, z is constant over the path generated by this parametric equation, set of parametric equations, this vector function. Well, this is a path in the plane, right? We draw some kind of curve. I don't know what it looks like. We could do it. But every point in this path makes z be constant. Oh man, that's a level curve in the domain of this function on two variables. And of course, if I differentiate on a level curve where all the z's are constant, I should get 0.